Greetings and welcome to my new calculus channel. And today I'd like to talk about a very important topic, one that is based on the following statement. It is easy to fix ignorance, but one cannot fix stupid. Okay? It's just impossible to fix someone who's stupid. And most of the mainstream mathematics community has terminal stupidity. So my historic geometric theorem has actually flummoxed mainstream mathematics community. Okay. They're still reeling after the thrashing I have given them. The obnoxious, ignorant, and incorrigibly stupid fools persist in their intransigence. So they keep forgetting that the HGT is a real theorem, unlike the bullshit they espouse, such as Gödel's theorems, not actually theorems, but provably wrong ideas, set theory, topology, which are both anti mathematical rot, or the clown show that is real analysis. Real analysis is based on a non existent mathematical object, that is, a real number. There's no such thing as a real number. So they are livid at me because I have outed them as incompetent stupids for claiming that h cannot be equal to zero in the finite difference quotient. So, for example, they've always claimed that if you have this, then h cannot be zero, okay? So, now, of course, you cannot put h equal to zero in a finite difference quotient, but the prize apes never understood that inside this finite difference quotient, we have both the tangent line slope and a difference, okay? And a difference. And they never realized that the sum of these is an arithmetic mean, okay? Is an arithmetic mean. The idiots talk about this as an average, but the word average can mean lots of things. It's not an average, it's an arithmetic mean, and it's based on the fact that f is smooth, by the way. So they dismiss the geometric fact that this is equal to f2 over h plus f1 over h, where f1 is this distance and f2 is this distance and h is this distance. Okay, they dismiss that because even their algebra skills leave much to be desired. And of course, they have never understood how algebra works, nor the difference between algebraic and geometric arithmetic. My holy grail of calculus summarizes these facts. So, geometry uses the unit and parts of the unit, okay, to produce 100% precision arithmetic in measure. However, algebra uses the abstract unit and or equal parts of the abstract unit to produce a generalized arithmetic measure which may or may not be accurate. So in fact, algebra still inherits the property of equal partitions of the unit from geometry. For example, it's not possible to divide 1. It's not possible to divide 1 by n equal parts in algebra. Okay? That just doesn't happen. You can't do it. When we say 1 divided by 2, like that, is equal to, when we say 1 divided by 2 is equal to a half, all that happens is that the 1 goes to the top and the 2 goes to the bottom. Nothing else. Of course, you can have an exception in this case where the numerator is greater. So if you have 5 divided by 2, it's still 5 over 2, but you can reduce this by something called obelus division, which means that you can say that's 2 plus a half, okay? So nothing actually happens in algebra. This is effectively a non-operation. This here is effectively a non-operation. So converting a half to 5/10, okay, or zero point 0.5 is not only a division operation. It involves multiplication, division, and addition. It involves all three of the four basic operations. It involves multiplication, division, and addition. Okay, all three of those. So, and if you, well, in this particular example of a half, you won't see addition, but if you try to convert a quarter, you will see addition. Okay, so a lot of operations are taking place when we convert a half to, or a quarter or anything else into base 10 or any other base. Okay, so for example, if we have a quarter, we have a quarter times 10 over 10, like that, which gives us 10 over a quarter times 1 over 10, which becomes 2 plus a half times 1 over 10, right, which becomes 2 times 1 over 10 plus a half times 1 over 10, right? And then, of course, this here becomes it becomes 10 over 2 times 1 over 100. And that gives us 2 times 1 over 10 plus 5 times 1 over 100. Okay, so the reason you can't divide 1 by 3, you can't convert 1 by 3 to base 10 is that you'll have to do this indefinitely. In other words, there is no measure, okay? So a lot of operations are taking place there. Let's just get rid of that. Now, the dismal fools of the last 4 centuries never realized that f prime of x, I hate it when that happens. I wish it would go to the small one. F prime of x plus q of xh is an arithmetic mean, okay? Thus, they missed the seamless connection between the derivative, which is slope, and the integral, which is a product of two arithmetic means. Okay? They missed this connection entirely. So they keep resorting to limit theory, which has no place in calculus, not realizing that the first principles method needs no limit theory at all. Calculus works just fine as long as the terms without h can be separated from the rest to yield the derivative, and the terms in h are the slope difference. So what's happening there is that you're changing the finite difference quotient that I showed you earlier, f of x plus h minus f of x over h, into this form here, whence you can set h equal to 0 in there. Okay, perfect legal. And that's in fact what you do in your first principles method, you know. And then another excuse I get is that because they lack and understand skill in algebra, they insist the HDT cannot be true, forgetting all along that the HDT is based on 100% geometry, not the circular rot of limits that infects their brains like syphilis. So another refutation, if you might call it that, it's not really a refutation, is that Q of x comma h changes. No, the slope differences as well as the slopes of non-parallel secant lines haven't changed in past perpetuity, are not changing, and will continue to be the same indefinitely, okay? The utter garbage of rate of change, instantaneous rate, etc., still prevail in their shit for brains. Calculus has nothing to do with any of those. So the orangutans of mainstream mathematics academia use circular reasoning by claiming that a function is smooth over an interval if it is differentiable on that interval, not realizing that smoothness is determined geometrically using tangent lines, not the other way around, okay? Because smoothness and because differentiability depends on the tangent line. So a function f is smooth over a given interval, p, let's say pq, if and only if one can construct no more than one tangent line in that interval, except for inflection points. And this is why the non-remarkable function such as f of x is equal to the absolute value of x is not smooth at x equals 0, because many tangent lines can be constructed there. So it has nothing to do with the syphilitic rot of left and right hand limits being equal. These depend on the tangent line. So a tangent line is by definition, not yours or the mainstream's, a line that meets a curve in one point, extends to both sides of that point, and never crosses at the point of tangency. So the foundations of mathematics are Euclid's elements, not the anti-mathematical garbage known as set theory and ZFC axioms. There are no axioms in ancient Greek mathematics. And if professors tell you they're about to teach you your profession by laying the foundations of mathematics and set theory, you can have a good laugh because set theory is not mathematics. Neither is logic. They're different fields of study entirely. One can fix ignorance, but stupid cannot be fixed. If you're not already a subscriber, become one. Follow me on academia. Tell your friends about this channel. Click like. I am actually on your side, believe it or not. Um, Also, if you have a few dollars to spare, contribute at the GoFundMe link. I'm John Gabriel, and this is a new calculus channel. Till next time, goodbye.